So one way that we can get an idea about how these descriptive and inferential stats work and how the p-value works is to do a little simulation. And that's what I'm going to do for you now. This is a simple spreadsheet that I made up to simulate sampling fish in our ponds. So if you look at a couple things here, we've got the sample in the first column. You see we've got pond 1 and pond 2 and the fish length. And I've got a button here for sample. And so basically what happens is when I press that button, it takes a random sample from pond 1 and a random sample from pond 2. And so that would be the first fish in each pond. And then I hit it again, and here I've got the second fish in each pond and the third fish. So it's a way to simulate going out and sampling fish. Okay? And so we're going to do this, and we're going to see how the stats change and how we use the stats to understand the data. Here's the first thing I want to do. I'm going to go to a different sheet here. And because this is a simulation, I can control the actual size of the fish in each pond. So it's not an unknown. In real life, it's an unknown. I don't know what the size of the fish are. But since I'm modeling it, I can control what the size is and then see how that affects things. So here I have pond 1 and pond 2, and the mean length in pond 1 is 250 millimeters, and the mean length in pond 2 is 10 millimeters. So I have set it up so that the ponds are very different. The fish in pond 2 are much, much smaller than the fish in pond 1. I do that on purpose. All right? Now, in real life, we wouldn't know that. Let's pretend we didn't know that. So I'm going to go ahead and sample. And here's the first fish I catch from each pond. In pond 1, it's 274 millimeters. In pond 2, it's 13 millimeters. Okay? Now, if we come over to the right, I have some descriptive statistics. You see I've got fish length for pond 1 and pond 2. And I've got the mean length, the standard deviation, the sample size, and the standard error. Now you notice that I'm getting an error for standard deviation and standard error. Now why is that? I'll give you a second to think about that. So what does standard deviation measure? It measures the spread around the mean. Well, we've only sampled one fish from each pond. So we don't know anything about the spread around the mean because there's only one fish. You'll note that the mean length is the same as the length from each of those fish. So now let's take another sample. So we're going to sample again. And you see in pond 1, fish 2 is 284. Fish 2 is 6 millimeters in pond 2. Now if I come back over to the descriptive stats, I can see that the mean length is much greater in pond 1. I can see that now I can calculate a standard deviation because I actually have 2 fish. And you can see that I have 2 fish from each pond there. So let's go ahead and simulate sampling 10 fish. Okay, so let's look at our raw data again. Now this is like the example I showed you earlier. If you just look at these raw data, it's pretty obvious that pond 1 has bigger fish. You can kind of eyeball that, right? Let's go back and look at the descriptive stats. The descriptive stats also suggest that pond 1 has bigger fish than pond 2. But again, how do we know? How do we know what is our uncertainty here? How do we quantify that? For that, we need a p-value. So let's go over here to the right where we calculate the p-value. Now you notice that the null is that there's no difference between the ponds. The p-value is 0.0000. So do we reject the null or do we fail to reject the null? You'll recall that the p-value is the probability that the null is true. And so that probability is 0.0000. So do we think the null is true? No. We can reject the null because it is extremely low probability that it's true. Now, I said there are no certain things, and here we've got a p-value that's 0. Understand that it's just because I haven't taken it out to any more decimal places. Okay? So the p-value is never going to be exactly 0, but it is so close to 0 as to be almost. So how sure are we that we can reject the null? We can almost say we're 100% sure that we should reject the null. But we never want to say that because in real life, if we took this out to more decimal places, there is some chance that the null is true, but it's an extremely small chance. Well, think about it. Why did we get such a small p-value? If we go back to the other sheet, you remember that this is a simulation, and we set it up so that the fish were much larger in pond 1 than in pond 2. And so when we sampled from pond 1 and pond 2, we got much bigger fish in pond 1. And that's why our p-value ended up being so small. Again, the trick is, how do we get this p-value? Now, if you look above the p-value, you see I have a cell labeled T. That's because the inferential stat that we're using here is called a t-test. Now, why do we use a t-test? We'll talk about that later. But basically, if you've got two groups and you're comparing the mean between those two groups, you use a t-test. The t-test is a formula that takes the mean and the standard deviation and the sample size from each pond, plugs them into a formula. We get this value called t, which is a test statistic, and from that value, we're able to estimate a value of p. So that's the difficult part. Now, it was very easy here because we just had Excel do it. But this is something you can do by hand. There are many software programs that will do this for you. The important thing is figuring out what is the proper inferential stat. And in this case, the t-test is the proper inferential stat. The last point that I want to make here is this p-value is dependent upon your data. So if we said that we're almost 100% sure we can reject the null, we're almost 100% sure that the fish are larger in pond 1. But that decision is based upon the sample we took. If we took a different sample and got a different p-value, then we change our decision. Remember, that's what we do in science. We always are willing to change our decision based upon new evidence. So let's do that. Let's go and change the mean length in both ponds. So pond 1 is 250. Pond 2, we'll say the mean length is 230. Now again, in real life, we wouldn't know this, but since it's a model, we can set it up that way. I'm going to clear the data. Okay, well, let's go sampling. I'm going to sample 10 times. Now let's go over here and look at the raw data again. Now here it's not as obvious, right? The mean length is much closer between the two ponds. I'm going to go back to the other sheet. you see we set it up that the average length in pond 2 was only 20 millimeters less than in pond 1. And when we do a sample from each of those ponds, you see that it's not very clear who has larger fish. Well, let's go to the descriptive stats. The descriptive stats suggest that pond 1, on average, has larger fish. You see in our sample, there's a little bit more spread around that mean in pond 1. We take these values, and the computer plugs them into the t-test formula over here, and we see our p-value is 0.6178. So, do we reject the null, or do we fail to reject the null? In this case, we fail to reject the null. The probability that the null is true is about 62%. And that's pretty likely that the null is true. Now here's the thing. If we go back to the original sheet, you see that they do not have the same mean value. Pond 1 does have fish that are slightly longer on average. How do we know that? Well, we're modeling. We set that up. But in real life, we wouldn't know that. So how come we're not able to reject the null? Well, it's because we only sampled 10 fish. And when we look at the mean and the spread of those 10 fish from each pond, we are not able to say conclusively that pond 1 has larger fish. And that's the uncertainty that gets built in when you do a sample. So how can we remedy this? What did we say we can do to help reduce the mistakes when we do sampling? What would you do in this situation? Well, if your answer was, I would take more samples, that's a good answer, right? So we were not able to statistically show a difference between the ponds because we took such a small sample. So I'm going to go ahead and keep sampling more. And as I sample, watch the n size tick up. And so again, this is simulating. I don't know why I did that. Oh, I know why I did that. I'm going to go ahead and freeze these panes. So it's simulating sampling fish from each pond. So if you look at the n size, now I've sampled 25 fish from each pond. And this is my model, so these are random samples. And if we look at the descriptive stats, we see that the average length was longer in pond 1 than in pond 2. And if we look at the t-test results, we see that our p-value is now 0.0086. So do we reject the null or fail to reject the null? Here we will reject the null. What is the magic number we use to decide if we should reject the null? Remember that magic number is 0.05. Usually we say that if there is a 5% or less chance of the null being true, we can reject the null. In this case, we have less than a 1% chance that the null is true, so we can reject the null. How confident are we in rejecting the null? About 99.9% confident. Is it possible that pond 1 has shorter fish than pond 2? Yes, it's possible, but based on our data, it doesn't seem likely. And that's basically the idea here. You see how we are able to take a sample, calculate descriptive stats from that sample, use those descriptive stats to create inferential stats, and the inferential stats give us a p-value. There are many other things I could show you with this spreadsheet, but I think that is a pretty good introduction into sampling and using descriptive and inferential stats. So let's go ahead and summarize what we've done so far, and then we'll talk about how do we decide that we should use a t-test or what inferential stat we should use. So let's wrap this all up now. What just happened? Remember that we had a question. Are the fish bigger in one of two ponds? We formed a hypothesis and a null hypothesis. We sampled both ponds. We measured the fish. We used descriptive stats to summarize those raw data. We then used the descriptive stats to get an inferential stat, which gave us a p-value, and the p-value allowed us to make a decision about the null. And that's statistics in a nutshell. Again, the general concept is not that difficult. The only tough part is figuring out which stat to use to get your p-value. And we'll talk about that in the next video, so I'll see you then.